Okay guys, had a few questions about how to do 2.1, some issues with finding velocity, things like that. So try to go through this quick, and if you have further questions, let me know. So for number 1, it says starting at the reference point, which is right here, use a ruler and draw 45.7 millimeters long points towards 309.6 degrees. All right. So if that's the case, I'm just going to lay my ruler right on top here and go to 309. So this is 310, 320, 330. So 309.6 is going to be right in the middle there. And line it up here, and I'm going to draw my line and measure it at 45.7 millimeters. Okay. So that's going to look like this right here. From here to here is 45.7 millimeters. And it lines up right here with 309.6 degrees. And you're labeling that P. We go over to number 2. And for number 2, it asks us to draw a line for the Juan de Fuca plate. And that moves at 19.4 millimeters towards 42.4 degrees. All right. So we're labeling that one J. Same thing. We're going to 42.4. So right here. And lining it up and measuring the line. I drew my line longer and then measured and erased away the extra, but to 19.4 millimeters, so 1.94 centimeters, right? So we got that. For number 3, we're going to assume that as much new lithosphere will be added to the Pacific plate as the Juan de Fuca plate to simplify things. And so you're just measuring from here to here, figuring out the middle. So this was 5 centimeters or 50 millimeters. So I went 25 millimeters or 2.5 centimeters to find the middle. And then drew my, I just connected these two lines to get R. That's what you're doing for number 3. For B1, okay, so for B1, we're drawing a vector from the reference point with the same length and orientation as the vector from point P to point J and labeling it P2J. And that vector represents the instantaneous velocity of the Juan de Fuca plate relative to the Pacific plate at that reference point. And the length of that vector is the speed. So we're figuring out how fast it's moving and how far. So to find that, this up here, I'm taking the same angle, so these lines right here should be parallel, but we're drawing it from the reference point, all right? And it's the length of P to J, so we know that that is 5 centimeters. So from here to here is 5 centimeters. To find this proper angle, if you have a protractor, you can use that. So I just put my protractor on top here, lined it up, and I measured this line here, and I found that it is at 17, if I line this up properly here, that it's 17 degrees. So that's 17 degrees plus 90 degrees, right? Because straight out here east is 90 degrees. So from this point level down to this point is 17 degrees, so that would be 107 degrees total. So I need to measure on this graph here 90, 100, 7 degrees, draw my line there, make sure that it is 5 centimeters, and that's my P2J. All right, so that's for number 1, and then my speed is 50 millimeters, right, 5 centimeters per year, and my azimuth would be 107 degrees. For number 3, we're just drawing it on the opposite side from here to here. Again, it's 5 centimeters or 50 millimeters, and we need to find that degree. So it's going to be the opposite of this, right? So we can just add 107 to this. So 107 plus 180 degrees would be 287 degrees, right? So that's how we're going to figure out how to draw that. The length, again, 50 millimeters. So our answer here, 50 millimeters per year at 287 degrees. All right, then we're finding the velocity relative to the reference frame. So R2P is what we're looking for, and so we're measuring from point R to point P. And if you remember, this was right in the middle, so we know we don't even have to measure. It's 25 millimeters. So for R to P is what they're asking us first. We're going to measure from here to here, 25 millimeters, and mark that for R2P. And then for our speed, 25 millimeters. And our azimuth is going to be the same as this one here at 287 degrees. All right, sorry, had an interruption. So we found R2P, and again, that's 287 degrees, 25 millimeters per year. And then for number 2, you're drawing a vector for R2J, which again is just going to be the opposite, 25 millimeters, and they're not asking you, I don't think, for the measurements, but you would know that that's 107 degrees at 25 millimeters per year. All right, so hopefully that helps for the questions that I've seen on section 2.1.